Hi guys, morning, welcome back. So today we'll definitely continue with the object equality and let's just see where we are in the course. Let's see some reminders and then we'll continue, okay? So your programming test 0 and 1, I'll definitely try to return them back to you, hopefully by the end of this Friday. I already distributed the submission to the TA. They should really get back to me about tomorrow afternoon. That's what they will do. And then I'll try to catch up with them. And then after that, I'll take a day or two just to finalize the result. And I'll return the result for both tests back to you. And then we'll follow up after that. So you're definitely on track. I'll keep you posted. And this week we have no assessment. We're just going to enjoy the more lectures about object equality. I'm hoping to take about 2 to 3 lectures to finish off the object equality lecture. It's definitely something a little bit tricky. It's going to apply certain tricky concept, which I'll also go slowly with, make sure you guys can follow through. And then after the equality, we're going to spend about the next about 6.5 or 7 lectures on inheritance. We're going to dive very deep and thoroughly into inheritance. You definitely deserve that kind of a depth about the subjects. We'll definitely try to start in time. All right, but next week is going to be written test number 1 during your live session. So this test will be a little bit different, not like a programming test. You don't have any starter project to import. You can do everything on E-class, and it's going to be multiple choice based. You can take a look at the practice question I released yesterday. Take a look at that, and then you can reach out to me if you got any questions. All right, please look at the guide. I definitely mentioned somewhere. Sorry, it's not here. Anyway, so there's a guide about the written test 1. Take a look. You will see some idea. And then for this week, lecture 12 and 13, I mean today and also Wednesday, they will be covered next week as well. So please do pay attention and also try to review maybe right after class. Drop by office hour and then catch up with the concept. They're all important. And for the review session, I do apologize. It's not the good time for everybody to really join. If you really can come, please do come. It's going to be this Saturday, 4 p.m. over Zoom. Right? I will host it myself and then I'll try to record the session, but the session is going to be run by everybody. If nobody show up, great, no questions. Right? So please try to really come. I can stay for at least 1 hour for that review session, and we'll see how that goes. All right, and then your lab number 3, I'm a little bit delayed in releasing it because I do want to cover a bit more about equality, object equality. That's something you will have to do for your lab number 3. Let me cover a little bit more, and then I'll release your lab number 3. I'll shift the deadline accordingly, so you don't need to worry. You'll still be given enough time to do your lab number 3. But that one should be quite straightforward to actually complete compared with the previous one. Your lab number 4 is going to be more challenging. It's going to be more about inheritance. But lab number 3, think about it's more taking a slightly relative break. From you still got to do a little bit of coding, but not as much. All right, any questions? All right, all good. I know it's going to be very busy for you in the coming week or so. Lots of midterms, I do understand. But since you come, make your visit worthwhile. I'll try to really try to maintain the clarity and also try to engage you as much as possible. Let's learn the stuff. I think we got 6 more weeks to go. Okay, it will run even faster after the reading week. Okay, quick recap from where we were. All right, so before the reading week, we basically finished off the last set of examples about JUnits combined with exceptions. So that's the last example we did. Basically, in this particular test, right, you want to review the details. And also there are certain practice questions you can also try it out. They are actually challenging for you to think about. Okay? So this particular test over here, we can divide them into phase number 1 and also phase number 2. You can see the fail assertion is placed in a different place, meaning that we got different expectation for the different phases. And for phase number 1, we do not expect the exception to occur. If that does occur, we're going to fail the test. However, in phase number 2, on the other hand, we do expect positive. We do expect the exception to occur. In which case, if it does not occur, if you can flow to the next line, we're going to fail the test. So where exactly you place a fail assertion is going to determine the design for your JUnit test. Just remember that. You'll definitely be tested on that in your written test 1. Okay, that's a good hint for you. Please review it and then let me know if you got any trouble. And we tried out different tracing example, right? And also for this, we got a few exercises. So this one here, just about if you only use console tester, like a system.out.println line. The principle you want to grasp from this kind of exercise is, if you only do system.out.println line, even if you say print out error right here, it is fundamentally different from just saying well, you want to fail the test, right? It's very different from the fail assertion. If you only say, I want to print out error to the console, the flow will still move on to the next phase, which is not appropriate. You want to make sure whenever the first error has been detected in your test, you have to move on, you cannot move on anymore. You have to fail the test right away, right? So think about this particular one. And I think some of you guys, maybe either from this section or from section G, you were asking, how can we fix this if we actually want to use the console tester? The short answer would be, you may want to use nested try and catch. That's something you will see in the practice test, right? So you may want to take a look at the corresponding question and solution to see how we can deal with this. And this exercise here is just about if you only have a single try and catch rather than two. We're basically going back to the JUnit tester. In this way, you wouldn't know whether the exception either comes from this phase over here or this phase over here. Because if it comes from this phase, we should fail the test. If you come from this phase, we should pass the test. So you really don't know which one to really go. So that's why you need two separate try and catch statements to handle that, right? So that's the essence for the exercise. And the final one was really about patternizing, the assertions. If you got a very wide range of the minimum and maximum values, in that case, rather than writing out 1,000 assertions, you can simply write a single one and put it inside the loop. So you can actually just adjust the minimum and maximum bounds for the loop counters. That's the way to go, right? So that's why I will also suggest you also try to practice that in your lab developments. All right, any questions? All right, so the next part about the recap is actually more important because we're going to build on top of that, which is the call by value principle we introduced you to briefly before the reading week. Okay, so if you look at the slides, it will be slide number 3. You want to remember, when does call by value really occur? Whenever you have a method call, you got call by value. It's like whenever you have a method call, you got call or callee, right? You have no choice. Just remember, whenever you have a method call, you have to identify several things. Number one, what is the context object? What's the type of the context object? CO, in this case, to the left of the dot. And what's the method we are referring to? Method n, right? And also, what is the argument we are passing in this case? And then accordingly, you want to go to where the method is declared and find out the parameter. And then there is some implicit variable assignment that will be done as a first step. Okay, let's talk about the principle very quickly. We do need that principle clarified before we can go on with more example. Okay, excuse me. So that's a setup. So let's say we got this method call here. We got context objects. You can see CO is declared as A. So M here must come from A. So we go to M that comes from A, right? That's how we draw the connection between the two methods, between the two sides. And we're calling this method here, and the parameter is simply param. And the argument we are passing is simply arg, right? You can see argument here can be any value. It can be something you read from the input, or it can be some concrete value. Doesn't really matter, okay? The most important thing is, you think about you're trying to step into the execution for this method call. That's what you're doing. And when you step into the execution for this method here, even before the very first line you can have control over, there is some implicit variable assignment that's done by the Java runtime, which is as follows. It will be the parameter assign arguments, this variable assignment. Okay? We will try to do one more set of examples today to reinforce. But when you study for call by value, number one, you want to remember the order of the variable assignment. That one I have no way around. You have to memorize it. Okay? You got to remember, when you step into this particular method call here, what is exactly param? The param is really a copy of the arguments. So param is assign a copy of the arguments. So that's the implicit assignment you have to do. Okay? Well, you don't really do it yourself, but it's going to be done in the Eclipse by Java runtime. So here comes the interesting consequence. Depending on what the type is for T, if T is simply primitive, like an integer or maybe Boolean, it's going to be quite straightforward. Just get a copy, right? In the case where T is more like a reference, for example, it could be person, it could be a point, any class you declare by yourself, for example, in your projects. In that case, you're also copying something. But what you're copying here is more like an address of the arguments that we're having over here, right? That's something we have to just do one more set of examples to brush up your mind. Because when we talk about equals method, in the second half of today, we will need to know about call by value. Any question about the principle here? Param, assign, arguments. All right. All right, so we did actually 2 examples here just to say the parameter could be integer, primitive, or it could be the reference type circle, right? So the call by value is going to work really consistent way, but just the value that's being copied could be different, right? I'll leave it to you to go over again this example here and this one here just to review. But we're going to do another one from scratch. So that's hopefully that's going to help. All right, before I start the new example, any questions? Anything? Awesome. Okay, let's now go over one more example. Okay, one set of example. So this is going to be from slide number 4. But I'm not going to show off this. I'm not going to go over the slides. I'm just going to show you step by step. But in case where you're studying, it's going to be slide number 4. And we're just making some assumption. Let's say we have a point class. We got x and y, and also we got constructor. We got get x, get y, and also we can also have some mutator. Either we can move vertically by increasing the y, right? That's something you learn maybe from linear algebra or calculus, right? Something like that. Or we can move horizontally, okay, like that, okay? And let's now talk about 3 different scenarios. Let's go one by one, carefully. Example 1, here. Let's say we are trying to test the call by value. Oh, we're just having JUnit test over here. So let's say we have a utility class, which is right here. And then we're creating we have a utility object here. And then we got 1, 2, and 3. 3 different methods. We're going to look at them one by one. For this current example, let's only focus on this one here. Let's try to get a feel about what's being achieved over here. In this method here, you're getting a parameter, j. Its type is primitive. And then what you're doing is you're saying j should be assigned j plus 1. You're trying to reassign j to be some different value to a primitive type. Okay? This is something that usually people would discourage you to do because you're not really modifying anything that's being passed right here as the argument. But we'll take a look. Okay? So let's just trace it together. Okay? So number 1, we have the utility objects. I don't need to visualize it. I just need to step into the method in a moment. And then I got number 2 over here. I got some integer I, which will be used as arguments. Okay, let me put I right here. I will be just 10, right? Right here. And then this assertion here will be very easy. You know, I will be 10 equals 10. So the assertion should pass. And let's now focus on this particular method call right here. Okay. We want to see how the call by value is going to work. As soon as you have a method call, you got call by value. So this method here, you can see that one there, u is the context objects declared as utility. So we know that reassign int must be a method from the util class, right? Let's go build a direction, build a connection. So let me just connect them, right? So think about this method here, declared, and also this method here being called. All right, so they are somehow connected right here. Call by value. Okay, I'll write it down. So think about call by value. And the call by value principle tells us it should be the parameter on the left-hand side. Assign the arguments on the right-hand side. The order is very important, right? This line here is going to be done even before the very first line of that particular method, right? You can think about this is more like, so number 4, we're trying to call the method. You can think about number 5 over here is something that will be done first before you try to step into and do number 6. So this order is very important. But you can never control about how number 5 is going to be done. It's done always the same way, just call by value, right? All right, so after that, let's now take a look at this. So this one here, j is assigned to I. What about number 5? It's basically going to create another variable here called j. It's going to take a copy of I. So 10, right here. And now here's kind of the important thing, right? When you actually call the method, you pass the value of I. Somehow in the method here, you're trying to change the value to +1. Are you changing this value here, or you're changing this value here? That's the thing you want to be very clear, okay? According to the code, let's see. So here, when we execute this code, it's referring to J, which is right here. It's this separate copy we just made by call by value. And that one there is actually going to, so let's say we execute this line here. So J, rather than 10, is going to be 10 plus 1, which will be 11. So now you can see we got I and J there of different values. They don't really change at the same time. We're only modifying the separate copy we have created by call by value. That's the most important thing you want to grasp. All right, so after this, we can go back to the last assertion, number 7. And that one there is going to check to see whether I remains to be 10. So I, you can see here, remains to be 10. You can see this one here is not modified. On the other hand, 10 over here is the copy that is modified from 10 to 11. Okay, I'll pause for one moment. Any questions? Please.
I just wanted to make the distinction. So this is specific to primitive, right? Not reference.
You can say that, yeah. This example here, you can see the parameter J there. Yeah, I do see what you want to ask. Yeah, let me just go a little bit broader. Okay, so this example here, you can see the method being called has a single parameter. That one happens to be primitive. The way we're going to handle primitive and reference are very similar. We're just going to copy the value of the argument into the parameter. It's just a matter of whether you're copying some simple value, like an integer or Boolean, versus copying address in the case of reference type, which we'll see in the next example. Yeah. All right, any question? Please.
When we pass J, because some programming languages have some keywords to restrict the argument to be changed, like const.
Sorry, say it again, Daniel. Sorry.
Some programming languages have keywords to prevent the argument to be changed, like const. C++. Can we use
It's a good question here. You can double check. Okay, let's say, for example, if you actually say I, you mean changed I over here to be a final, like a constant? Or right here? Okay, this one I'm not exactly sure. So what your fellow student was asking is it possible to actually redeclare this one to be like a final int j, where final tells us that we cannot really change its value? We may have to try it out. I'm not exactly sure. Yeah, but I would say if you somehow come from a different programming language, you maybe just try it out and let me know, please. All right, okay. All right, let's now move on to a different, before that, go ahead.
Is the call by value, is that the parameter, or is that just the act of like linking the parameter with the argument?
You can definitely think about linking the parameter and the arguments. So call by value is really linking the two words. So you're linking the method that's being called, the method definition, more like a block of code you're going to execute, with the actual method call you're making. So you're saying, what should be the parameter j I should really use in order to manipulate every line of code in the actual body of the method? The way to really initialize j is by using the argument value I. That's what the callback value is trying to do. You can think about in some way the callback value is really trying to initialize your parameter by the arguments. But you don't need to do that initialization. The behind the scene Java runtime will do that for you. Yeah. All right. So let me just give you a little bit look ahead. So we basically just covering some principle and do some simple example for call by value. There are two major usages for this course about call by value. One is for the equals method, which we might see a bit today or Wednesday, either way. Another big one is when we talk about inheritance. Right? So these are the two things we're going to see. But call by value is a very important principle. Okay. All right, let me move on. Okay, let's now move on to reference type parameter. So we still got util, and also we assume we got a point class right here. Okay, we assume. And the method we are talking about is this method here that we're calling, right? Just take a quick look. Okay, I'll make it a little bigger. So this one here, you can see the parameter is point as opposed to int. So that would mean later on, when we do call by value, you're going to say parameter q is assigned something. And the question mark here is going to be whatever argument you're going to pass to the method call. Depending on which method call it is for this method here, the question mark here might be different value. But what's going to be important is what we're copying is the address that is stored in this right-hand side into the queue. That's what we're going to see. All right, let's try to trace it together, and you will see what I mean. All right, again, let's now trace by labeling the sequence. Okay. Number one, we have our utility objects. Number two, we are basically initializing a point object called P. So I would say P stores the address of a point objects. Okay. And then we're going to have the point over here where we got X and Y. Yeah, you can definitely step into the constructor if you wish, but I'm going to skip that part. 3 and 4. Okay, 3 and 4. So that's a P we have created. Simple stuff. All right. And then we got another reference over here. That one just to illustrate. The P here will stay the same throughout the method call. That's something we'll show to you. Okay. So I'm creating another alias right here. Number 3. So this one here is saying I have another variable called ref of P before. Ref of P before. That one there is going to copy whatever that's stored in P. So that means it is going to point to this object here. So when you are studying for written test 1 for next week, you got to watch out for this kind of reassignment for the references. It's going to be everywhere in the test. Okay. Okay, and then the next one. Let's say we try to make this method call again. Okay, this is a method call, and this is the method that's being called right here. All right, and let's again try to make it explicit for you. So this is the method we are trying to step into, and this is the method that's being called right here. Okay, so to connect them, we got call by value, and call by value is going to be the parameter is assigned the arguments right here. So we're going to get Q is assigned P. Okay, it's a little bit small, but hopefully you can still see that, right? Maybe bigger, right? It's going to be actually Q is assigned P. So Q is the parameter, P is the arguments, right? That's a call by value. And what would that do? That would do the follows. So here, Q is actually going to copy whatever address that is stored in P. Diagrammatically, P and Q will just point to the same objects. So think about this part over here is done by call by value. You can think about, let me make a little bit more annotation here. P here is the arguments, and Q here is the parameter. Any questions so far? We're still doing copying. It's just that rather than copying just integer value, we're copying the address that's stored in the arguments. All right, let's now move on. And let's see what we're doing in the next line. So when we execute, let's say right here. So here, we are trying to create a new local variable, MP. MP actually points to a point objects right here. And then it's going to be 6 and 8. Local variable. So we got X and Y, 6 and 8. All right, let's look at the critical line. So here we are trying to reassign this one here. Okay, just before that, so number 4 will be this method call here. Number 5 will be the call by value. And then number 6 will be the creation of the local variable. And what we're looking at now is number 7. Okay, just be careful about the sequence. Okay, for number 7, we are saying Q is assigned MP. Right? We're doing some aliasing, basically, right? Q is going to point to wherever MP is pointing to. So we are modifying Q. And then Q is now going to point to wherever MP is pointing to. Let me undo it, because you can see when I actually do that changes, I'm not really modifying the P, which was the arguments, right? That's something you want to also convince yourself, right? So again, this one here, Q, rather than pointing to the original objects, is now going to point to NP. Okay, so this is very important. Okay, I'll write it down. Star. Okay, I'll put it here. So here, only Q, a copy of P, is modified. P itself is not modified. So that would mean when I actually call this method here, I'm passing the value of P, even though inside this method here, I'm reassigning the arguments, but I'm only reassigning a copy of P. I'm not really directly reassigning P itself. So that's why P here is not going to also point to MP. That's my point. It's not going to. Okay? So I'll write it down too. Okay? So it's incorrect. Incorrect to expect that P is reassigned to NP, right? So this is so important. Incorrect. All right? All right, so after this, we're going to do some assertion, okay? So now we are up to number 7. Okay, let's now do number 8, okay? So number 8, number 9, and also number 10, right? So we got 8, 9, and 10. Let's take a look at that very quickly, okay? All of them will pass. What about number 8? We're saying that P and reference before. So P and reference before, they keep pointing to the same object. P never got reassigned. So they stay the same. All right? And the next one there is a P dot get X. P dot get X stay to be 3. And P dot get Y also 4. So in this particular example here, we are saying that when your parameter is of reference type, what you should really try to avoid is to simply reassign the reference directly, because the Q you're reassigning is only just a copy of P. So when you change the Q, you're not going to modify the P at the same time. That's not going to happen. Now the question is, what if I really, really want to modify this object here? That'll be the next example. The way to do it is, rather than trying to reassign this reference to another object, which you can never do, because it's always a copy in the parameter. The way to modify this object here that's pointing to by the arguments, you have to call some mutator method using aliasing. That's something we'll see in the next example. Okay. So whenever you got some parameter of reference type, you're always going to remember yourself. Can I simply reassign the parameter reference to something else? If you do it, it's only going to modify just that local copy, just the parameter, but not the original arguments. But if you really want to modify the objects that's being pointed to by the original arguments, you got to do something else. But let's see some comparison. Okay, it might sound a little bit dense, about the discussion, but try to revisit maybe when you study. It does contain lots of details you have to watch out. Okay, let me just move on. Okay, so you can see the big picture. We're going to do something very similar. Okay, so the parameter here is still a reference type. Status. Oh, sorry, right here. It's a different method. So parameter is still point. All right, it's a reference type. But this time, we are not really trying to do anything like a Q is reassigned to something, which we saw already. What we're trying to do is, why don't we say Q dot some mutator method, which means we're going to follow through whatever address that is stored in Q, which we know because of call by value, Q is going to share the same address as the argument P. So if I'm trying to modify the object that's pointed to by Q, I'm modifying the same objects that's pointed to by P. In that way, I will be able to do something. But we're going to visualize it. Okay, that's just more like a quick summary. All right, let's now trace again. Okay, we still assume we got this point class, and then we got move vertically and move horizontally, right? For the definition, you can take a look. For that one, I'm just going to directly manipulate. All right, let's do it again. Number one, create a util. Number two, we're still going to create a p, which will be used as arguments. So p here of type point. And we got x and y, 3 and 4. 3 and 4. All good. And then we still have this reference over here. Number 3 is called reference of P before. And that one there pointing to the same objects. All right. And let's now take a look at the method call. Okay. This one here is important. Okay. This one here and also this one here. Okay. First of all, call by value. Call by value tells us the Q here and the P here will be connected. Think about Q is going to be initialized by the value of P right here. So the call by value. Call by value is going to do Q is assigned to P. Okay, that's the number one thing you got to get right. If you get P is assigned to Q, you just got the whole thing wrong. Okay, Q is assigned to P. So what this will do is this. So think about number 4 is to call the method. Number 5 is going to be this call by value, implicit. Okay, so Q is going to point to wherever P is pointing to. Okay, again, you can note to yourself, P here is the arguments, and Q here is the parameter. But once you get more proficient in tracing it, you don't need to, but just in the beginning. It's good to clarify about where we are. Okay? So all the preparation is done. So now we're going to trace about these 2 lines, 1 and 2. What we said earlier was if you try to reassign Q to something else, P will just stay the same. But now we want to say we do want to modify the same objects that's being pointed to by P, which is the arguments. The way to do it is by, well, just using Q, because Q is a copy of the address of P. So what we do is, let's see. So this will be number 6. So number 6, Q the move horizontally. So Q here, if you follow through, is going to be this object over here. Move horizontally, we're going to modify the x value. So it's going to change x from 3 to 6. Right? Move horizontally. And then we can go for number 7 here. And Q, again, the same context object. Move vertically, changing the y value. So Q here, again, follow through this pointer here. And change from 4 to 8. So what you can see is what we can do by call by value usefully. Given that the arguments and parameter point to the same objects, if we are trying to call mutate a method from either reference, it's going to have the same effects on the same objects. So we're really modifying this blue object over here and just change to 6 and 8. All right. So after this, let's now check some assertion. So now let's now do 8, 9, and 10. Okay. Let's see that. Okay, number 8, P and reference before. P and reference before. P will never get reassigned. You can never do it from another method being called. Okay? And also P dot get X is now 6. As opposed to before, you can see P dot get X remain to be 3. Right? That's something you want to compare. And after that, P dot get Y will be 8 over here, right? Because it has been modified as well. Any questions? So call by value is not very difficult. I think just got to remember the principle about how you can initialize a parameter value by using the arguments and just get the order of the assignment right. And also always remember to visualize that line behind the scene, implicitly, before you do anything else. And we'll need this principle very badly when we talk about the equals method. Yes, please.
Is there a way to mutate primitive type?
Is there a way to change? Okay, change a primitive? Okay. That's a good question here, which I think is a valid one. For those of you who might be more like a C programmer, or maybe did C++, maybe C# as well, maybe some programming language. Okay. In some programming language, for example, if you got primitive, for example, let's say in C, there is a way to say, rather than just getting this value, I want to get its address, something like that. However, luckily, you don't need to worry about it in Java. You're not allowed to do it. Okay, it's just not allowed. Okay? So in the case of primitive, you just have to remember you always just get a copy of the original arguments. You have no way to really get the address of the primitive. Right? But of course, if you study C in 2031 or 2032, you will have to worry about it. Yeah. All right? Okay, if no further question, I would suggest we do, go ahead, please. Good question here. The question was, let's say this. Maybe you are thinking, let's say int here, rather than this, can I change that to be integer? It's definitely a valid type for a parameter. As soon as you do this, you're basically not really dealing with primitive type anymore. You're really dealing with like a reference type point. So everything will follow from there. Right? So let's say, for example, actually, it's a very good question. Why don't we explore that together a little bit? Let's say I got some void method. Let's say m. I'll sketch it a little bit so everybody can get an idea. Let's say integer objects. Okay, let's say that. Okay, so this is the method that's being called. And let me just ignore the context object just for now. You can easily reproduce that. So let's say right here I have something called maybe some method m. And then, just before that. Okay, let me just also create that arguments. Let's say integer, let me say I. New integer, and then 23, for example. Okay, and then I'm calling n I. Okay, and what I want to do there is I can say n is assigned new integer, first of all, 46, versus if I simply do, I need to look it up, but there might be a mutator there. I can try. Okay, let's say at. Okay, not at, so not m, beg your pardon. IO, and then IO dot at, let's say 10. Okay, let's do that. So I'm basically showing you two possibilities. Either you're trying to reassign the IO into something else, or you're trying to call some mutator method on IO. I got to double check on this method here. Okay, I'll let you know next time. But let's assume there's such a mutator method in the integer class. Let's see how these two lines are going to be, excuse me. Let's see how these two lines are going to be different. Number one, we're going to create this integer value. I is basically going to be some integer objects here. And there is an attribute called value right here. And let's put it 23. Okay, that one's straightforward. And then call by value. This part here, and also this part over here, call by value. Call by value, IO, the parameter is assigned I, the arguments. Okay, that one there, right here. And then we say IO is also pointing to the same objects, right here. Okay. Let's see what's going on here. Okay. And then let's see here. 1, 2, and then 3. If I do number 4, IO is simply reassigned to some other objects, right? And other objects that we are creating. So that one there is simply integer with the value. Let me write better. That one there is pointing to a new object right here. Oh, sorry. Let's see if that can work. Okay, that's fine. So this will be integer. And then we got value 46. Right, you can see this line here is not really changing the original arguments. It is not, right? Like how we said earlier. Okay? Why don't we say this? Let's imagine that this is alternative. Alternative. You know what? Let me just put them in a different page. I think that may be better. Okay? You will definitely see exactly what I want to say. Give me one moment. Let me make a copy of it. Okay, so for the very first one there, so the first one here, we simply reassign to this object here, okay? And the second version, I'm just going to delete this one here. Instead, for the number 4, I'm actually going to do io.add, and then 10. Okay, it's a different version. So in this case, io, I know that it's actually pointing to the same object. So this one here is no longer applicable. Okay, I can get rid of it. Okay, so you can see io here, because the call by value is pointing to the same object as I. So now when I say io.add 10, it is actually going to modify this to be 33, right? Just as we illustrated before. Let me recap. So this example here should be no surprise to you, even though you're calling something called integer. Integer is a wrapper class, which is a reference type. It's one of the library classes in Java. Because it capitalized I, so give you good hints, it's a reference type. So the way we're going to deal with it is just like the reference example. So scenario number 1, if you're only trying to reassign IO to be a new object, it's only going to reassign the IO to another object here. The original I here doesn't really get reassigned, as we said earlier. How can we change this object here? If you want to change it, you got to call mutator method, and we'll add 10 to it. Is it clear to you? Okay, good. Yeah, we just got to double check whether the mutator method is called add. I'll go double check. Any other questions? Good. Okay, good. Let me just do a very quick review, and then we'll take a short break. Okay, a few minutes, quickly. So we are now good with the call by value, so let's now dive into object equality. So today we can do some nice introduction, and I want to do a little bit demo on the Eclipse as well. That's also very important for you to see. So let me just do something very basic as a review from before. So this one will be from slide number 11. Okay. Okay, slide number 11, basically just kind of review about how you can use the equals and the equals method. Okay, so you can look at the bullet point yourself, but I'm just going to build from scratch some notes. Okay, let's talk about equality. Okay. All right, so basically there are two ways for you to do equality in Java. Either you can use the equals sign, which you definitely have done a lot from the first year, or you can use the equals method. However, you got to be very careful about the equals method. I'm going to say that, just say some basic first. Okay, let's talk about primitive type. So to start with, let's say we talk about primitive. Like an int, boolean, etc. If I got integer I, 23, integer j, 46, and we know pretty well, if I simply say I equals j, it's going to give me true. Straightforward. Oh, sorry, false. beg pardon, should be false. Of course, 23 is not equal to 46. False, for sure. Just comparing value. Okay, so for primitive type, you can definitely do equals to compare just the value. Okay, what you cannot do is to call the equals method. I'll show you why. I'll show you how. The equals over here is not something you can do. It's going to be compilation error. So for example, let's say here, if I simply say I dot equals j. If you think about it, conceptually, it simply doesn't make sense because the dot here to the left of dot should be the context objects. I is a primitive value. No way it can be a context object. So this is not even going to compile. Just remember, if you got primitive value, you can only use equal. That's the only thing. All right? So this one here is not going to compile. Compilation error. Okay, that's all I want to say about primitive, which is pretty straightforward. What about reference type? Okay, let's talk about what you know, and we'll take a short break. After the break, we'll talk about something you may not know. Let's see over here. Give me one moment. There we go. Reference. Okay, let's just mention something that we already know. So let's say we got point P1 and new, and also we got point. Let's say 3 and 4. And let's say we got another object here, P2. It's going to be a different object, so different addresses. So let's say point, but they happen to be geographically the same location, 3 and 4 as well, but they're different references. So over here, if you simply try P1 equals P2, we know pretty well it should be false, different addresses. We can think about different address value. Because different address values. All right, all good. However, for the reference type, there's another thing you can always do. So you can definitely do equals, which will compare references. You can also do equals. This is also possible. However, this is where I'm going to just give you some idea. Okay, it's not going to be very thorough because we're going to see concrete example after the break. So the equals over here, there are two possibilities. Either a version from objects. It doesn't make sense for now, that's okay. I want to mention the name, but we'll see exactly what I mean after the break. From object class. Or a version that's defined in the point class. So this is telling you basically whenever you call equals method, in general it's not as straightforward. Either the equals could be from some class called objects, which I'll show to you after the break, or the equals method may be coming from the class itself. It depends. That's something we will have to go over the example to determine. All right. For this point here, don't worry too much about understanding completely. That's something we're going to see. Okay, I just want to mention a summary. All right, if no further question, I'll suggest we'll take a short break and then take attendance, and then we'll resume. Okay, if you can get your eye. All right, so before the break, we spoke about using equals, especially equals operator. That's something we knew from before. Let's talk about the equals method itself. It's a special method you have to know for OOP, not just in Java. I think in other languages, they also have equals as well. Okay, so let's now look at the first example and get something very important. Okay, I'm going to show you on Eclipse as well, but let's now only take a look at this class. It's a single class, very simple to define. It's called point v1, version 1. Okay, we got x and y integers, attributes. We got constructor here. We got x and y, and then this dot x, this dot y. Very straightforward, and that's it. So there's only one method in the class we explicitly define, which is the constructor. That's it. All right, and then when I try to use it, let's take a look. I have a class called pointTester. Let's say we use a console application. I create P1 and P2 of type the same, point V1. And then I just initialize to be 3.4 and 3.4. And here I'm calling a method that is not explicitly defined in point V1. All right, let me say that again. Here I'm calling P1 dot equals P2. However, P1 is from point V1, the context objects. Point V1, I cannot find any definition of what an equals method is. That's my point. All right, everybody can see that? Okay, so now, two questions. Question number one. Does this line compile? Yes, it does, okay? Actually, so in some way, I want to really emphasize this one here. If you think about what we kind of said before, we said before, whenever you want to call a method, it better be defined in the corresponding class. If it is not defined, it wouldn't compile. However, the situation here is not exactly that simple. The equals method here, even though it's not explicitly defined in point V1, but there is something more complicated behind the scene called inheritance, which we're going to touch upon a little bit later in much more detail. But for now, I just want you to know, in this case, equals method is just going to be implicitly defined for every class you're going to create on your own. Okay? So first of all, it's going to compile. The reason is simply because the equals method is implicitly defined in every class due to inheritance. But there's inheritance, I'm going to maybe give you a little bit of diagram a little bit later to see. All right? So the first question here is yes, it's going to compile. And the second question is, at the runtime, I'm going to show you on Eclipse. If I put a breakpoint right here, okay, let's simulate what we're going to do. Let's say I put a breakpoint right here. And then I step into. If I step into this particular line, I want to see which method is being called. In this case, equals method should be called. But since we know equals method was not explicitly defined in point V1, so which class should the equals method come from? All right? If you know the answer, maybe you know the answer, that's okay. We're going to find out, okay? It turned out it's going to be a class called objects, all right? So it's going to be the objects class equals method being called in this case. All right, let's verify that. Okay, so you can also try that on your Eclipse as well, but let me try that on mine. Okay, all right, so let's see here. In the point V1, as I said earlier, you can see the whole definitions here. We don't have any explicit definition for the equals method, no. And then you can see number one, in the pointTester class, when we wrote a line like this to say P1 dot equals P2, P1 comes from point V1, but it still compiles, number one. Number two, which version? What I will do is I'm going to put a breakpoint right here in line number 7. Okay, line number 7. And then I will launch the debugger. Okay, take some time. Okay, let me switch to the debug perspective right here. Okay, I'm now pausing at line number 7. Now if I step into, I should be able to see which equals method this comes from. It's going to be a class called objects, but let's see. Okay. If I step into, you can see that one there that opens a tab called object.java. So this object class is not something you declare or define yourself. It's a library class that every class will actually get access to all the methods in the object class. That's something I will talk about a little bit more. But that's something I just showed to you. If you step into the equals method, it's just going to look at the equals method in the object class. And that one there is basically just doing this equals obj. Meaning that by default, if you don't explicitly define the equals method in your class, when you call that equals, it's just going to boil down into comparing references. Before I take a question, let me write something down. Okay. So that would mean over here, this one here simply boils down into P1 equals P2. You can think about the P1 here is the this. And P2 here is the obj. If you look at what we have here, you can see that this is the context object. Obj here is a parameter, right? The parameter called by value is going to take whatever the argument is, right? Question?
How many methods are in the object class and how many of them are actually useful to us?
As far as this course is concerned, I would say the equals method for sure. That's the number one important. And also the toString method. These are the two. I think once you get to the more advanced course, maybe data structure or algorithm, if your professor actually wants you to maybe implement something in Java, there's something called hash code. It might also be applicable. But I would say for this course, equals and toString. Yeah. Question?
How is like equal working in the method, but not if you like assign it? Like if you do it like simply P1 equal P2.
Okay. Good. Okay, guys. Yeah, I'll talk about it. So, guys, so hopefully the demo is kind of straightforward, right? What I'm trying to show to you is if I simply say step into P1 equals P2, I will actually go into the method equals from the object class. So this is what we call the default version of the equals method, which will only compare references. Okay, so that's the main point. Okay, but let me just make some notes and also address your fellow students' question. Okay. So here, when we when we got P1 equals P2, it will boil down into just P1 equals P2. If I do another line, let's say separate line. Let's say this is number one. If I can do also number two. If I simply say print line, and then I say P1 equals P2, separate lines. Okay. Syntax-wise, this is a method call. This is using the relational operator equals. But in this particular case, because we don't have any explicit definition for the equals method, so these two will turn out to be just the same. Okay, but we'll speak more about it. Okay, so here, just want you to be aware about this kind of complexity, and we got to talk about systematically how we can distinguish between cases. One here and one here. Okay, let me write something down. Okay, here and also here. Effectively the same. Because no explicit definition of the equals method in the point class. Okay, we'll repeat the point again, actually just in another example. Okay. Okay, I would encourage you to give a try on this particular step into breakpoint in debugger on Eclipse, but you might run into some issue here. Okay, so for those of you who want to try, okay, if you want to try this out in Eclipse, it is possible you might need to set up something called attaching the source for your runtime. But if you run into issue, you can reach out to me. Maybe office hour, I can help you with that. I just tried it out earlier this morning. You may have to attach the source of your JDK, Java Development Toolkits installation. So this is not really pleasant to deal with, but just in case, if it doesn't work on your machine, you can reach out to me. We can see if we can make it work. Okay. Anyway, that's an aside you want to watch out for. All right, let's now talk about the issues about equals systematically. We got about 16 minutes. We'll see how much we can go for today. At least we can get some basic clarifying. Okay. So the running example we're going to do will be the point class, just to make it simple. So let's not worry about the object class just yet. Let's only look at these two classes, this class and this one here. Okay. One of them is called point v1, version 1. The other one is called point v2, version 2. So the difference between them goes like this. Well, what do they share similarly? Both of them got x and y, the attributes. However, in the case, both of them got a constructor for the point. In point v1, we don't have any explicit declaration or definition for the equals. I'll write it down. So point v1 over here. So number 1, no explicit declaration or definition of equals. On the other hand, the point v2 class, there is some explicit declaration and also definition of equals. That's the number one difference you want to tell between the two versions. So we're going to play between the two versions to see how the equals method is going to work. So version number 1, no explicit equals. For version number 2, we do have the explicit equals. Okay. And let's talk about the object class. Okay. So this is something that's going to involve a bit about inheritance. I'll try to minimize the discussion about inheritance because we're going to talk about it quite extensively after the first 2 or 3 classes. Okay. So let's see what we should know. Okay. The object class. So the object class over here is a library class. And we say that it is the parent class of every class. So by definition, if you're creating a new class in your project, any class, point collector, vaccine, distribution center, or app shop, whatever class you're creating, the object class immediately becomes a parent class of yours. So what does it really mean when you have a parent class? When you have a parent class, that simply means everything that's in the parent class is going to be inherited to your class. In this case, the equals method. Okay, I'll write it down. So we say that this object here is the parents. Or it's called a superclass. And in the case of point v1, and similarly for point v2 as well, we call that the subclass or child class. Okay, let's now talk about what you should know just for inheritance for now. Okay, we have parent class, we also got child class. Okay, you can think about the direction goes in this way, like that. All attributes and methods. It's not exactly precise, not like accurate, but I think at this point, I think it's valid to say that. Just anything you declare in the object class is going to be inherited to the subclasses. Inherited to the subclass, okay? So the direction goes this way, okay? So for example, the equals method here is going to be inherited to the point v1. That's also going to be inherited to point v2. Okay, it's going to be inherited. That means you don't really have to explicitly define that method again. It's just available for you to use. Okay, that's what inheritance really means. Okay. Now, for point V1, let's now talk about this. Point number one, we say there's no explicit declaration or definition for the equals method. The consequence of that is this. So that means the version of equals from the object class is used. Like this way here. Whenever you're creating, let's say P1 and P2, they come from point V1, which has no explicit declaration for the equals method. In that way, because point V1 by default is a child class of the object class, it's going to inherit everything from the object class, including the equals method. In that way, the P1 for P1 here, when you call P1.equals, it's simply going to use the version from the object class. It's a default version. Okay, that's a scenario number one, which we're going to go through some code example again. Okay. Okay, let's now highlight it, and then we'll talk about another case. There's also a special term I have to introduce as well. So the version of equals from the object class is used. You can think about the default case. Default version. There's always one version for equals, at least, the default version. What about point V2? All right, there's a special term you have to learn right now. It's called overriding. Okay, I'll write it down. So you can see here, public Boolean equals. Public Boolean equals. This method here and this method here really refer to the same method. You can think about this as the default version that will be automatically inherited to the point V2 class first. However, at the same time, we choose to also define an alternative version of the equals method. As long as that's the case, the default version is no longer applicable. We're going to use this version here, and it's called the overridden version. Okay, I'll write it down. So the equals method here is called the overridden version. Or you can say redefined version. In Java, they like to talk about overridden. However, I think maybe in the layman's term, redefined, maybe a little bit more understandable. We are trying to redefine something we got inherited from the object class. Redefined version. Okay. So overridden or redefined version. All right, so let's now make another point here. We said earlier, because we got explicit declaration of the equals method in the point V2 class, the consequence is this. The default version of equals, okay, let me write better, of equals from objects no longer applicable. Okay, I'll highlight it. Default version from object no longer applicable. The only thing that will apply for the equals method will be the overridden version that we define here. Okay, that'll be number 3. Okay, so number 3. Number 1, number 2, number 3. The overridden version, O-V-E-R, the overridden version in point V2 is used. All right, that's something we'll also keep tracing to really emphasize the point. Okay, let me recap very quickly. The only thing you want to know about inheritance for now, number 1, the object class is one class that's the parent class of every class you're creating in your projects. As soon as the object class becomes your parents, everything that's defined in the object class is going to be inherited to the class itself. In this case, the equals method in the object class is going to be inherited to the point v1 and point v2. However, the situation will be a little bit different. In the case of the point v1, you don't really have any explicit redefinition for the equals method. So whenever you say you create some point v1 object and they want to call it equals method, it's going to boil down of using the equals method. That's default because you don't have it. On the other hand, in the case of a point v2 class, you do have some overridden or redefined version. In that case, the default version that's inherited is no longer applicable. At the runtime, Java can actually tell this. You don't have to know, right? Just conceptually, you got to tell in your particular class, do you or do you not have that explicit redefinition of the equals method? If you do have it, use that redefinition, the latest version. If you don't have that redefinition, use the default version. So that's the principle. All right, again, this is still like a hand waving, like a sketching the idea, but we're going to see exactly how things will work. Okay? Because when you actually develop your project, sometimes you might find it useful to have your own version of the equals method. But in some cases, you don't really have to. You just use the default version, comparing references. That might just be enough. So it really depends. Okay. All right, so why don't we talk about just one example, okay? Very quick. That one is more like a repetition, okay? And then we'll continue the rest from Wednesday. 5 minutes, okay? So let's say the default version. So now the context is very clear. So we have our point v1 class over here, right? We only got attributes and also a constructor, no explicit. Again, let's emphasize the point. No explicit redefinition or overriding of the equals. Okay, negative, no. Because no, we are just going to call this version instead. Okay, so think about this one here is inherited to the point v1 class. And you will see I put a keyword here called extends. You don't really have to use this keyword. It's just keyword in Java. So whenever we got a class extends another class, so we say that a child class extends a parent class. But you don't really write this extends yourself. It's kind of implicit, right? Whenever you create a new class, Java interprets that way. Okay? But we'll talk about extends way more later. You're going to know how to use it in your lab number 4. Okay? Let's just try to trace the program to see what's going on. So what we have is we have 3 objects here. Okay, let's see here. So we got point P1, P2, and P3. So P1 and also P2 and also P3. Okay, P1, P2, P3. Okay, let's now fill out the value. So 2, 3, 2, 3, and 4, 6. Okay, straightforward. And let's now do some comparison quickly. When I say P1 equals P2, P1 equals P2, false. Different objects, right? That one should be false. P2 equals P3, P2 equals P3, also false. Different objects. All right, very good. Let's now see the next few lines and see what happened. So let's now take a look at the first one. When I say P1 dot equals P1, okay, this one here. So this one, let me just number them. So let's say line number 7, right? Okay. So line number 7. When I say P1 dot equals P1, we want to know which version of the method, of the equals method should be called. And to be more precise, this is the principle you also need to know. You want to look at the context objects P1. P1 over here is now pointing to an object of type point v1. Okay? The object that's being pointed to is so-called dynamic type. That's something I also need to introduce you to. Okay? It's called a dynamic type. of P1. All right. So here, the context objects P1 points to an objects of type point V1. And we say that the object that's being pointed to is called a dynamic type. Points to an object of type point V1, which is this type over here. It's called a dynamic type of P1 is point V1. Okay, once we got the dynamic type, we're going to call the version that's in the dynamic type. The equals method right here comes from the one, okay, I'm running out of space, inherited from the object class. Okay, I'm just running out of time, so let me just continue from here, maybe from Wednesday. So what you want to review before Wednesday is you want to maybe go back to this very first example I spoke about, the basic over here, and then try to see if you can reproduce this in Eclipse, and then look at this first example here, the sketch about different versions. We're going to dive much into the different phases for equals method. Thank you so much. Okay, I'll see you on Wednesday.